the amount of time it takes to complete one cycle. الفترة اللي هي البريود معناته الوقت المستغرق لإكمال دورة واحدة. And we need to know the frequency. This means the number of cycles in 1 second is the frequency of oscillation. A large variety of size and shapes of transducers are available to perform specific function, but they all have a general design. هناك العديد من المحولات بأحجام وأشكال مختلفة، ولكن كلها تحتوي أو صممت بديزاين واحد. The crystal is designed so that its thickness is exactly equal to half the wavelength of the ultrasound wave to be produced by the transducer. The crystal oscillates more efficiency. The frequency determined by its thickness. أهم شرط هو أن يكون سمك البلورة مساوي لنصف طول الموجات الصوتية التي ينتجها من محول الطاقة. The frequency that corresponds to half of the wavelength is called fundamental resonance frequency of the transducer. هناك مثال يخص حساب the fundamental resonance frequency of lead zirconate titanic crystal. المعطيات هي السمك 1 ملم، وسرعة الصوت 4000 متر على الثانية. ذكرنا احنا لازم عند صناعة او ديزاين للترانسيوزر يجب ان يكون الحدود هو ضعف الثيكنس اي سمك الكريستال. اذا نضرب سمك الكريستال في 2 للحصول على تردد الرنين. اذا هنا حيكون 2 meter. This is the resonance frequency اي تردد الرنين الموجي. بصورة عامة عندنا الفيلوسيتي السرعة للموجات حيث تكون السرعة تساوي الطول الموجي على الزمن. هنا الزمن اللي هو 1 على تي هو التردد. لذلك بهالطريقة هاي نحسب الفاندمنتال فريكونسي من تطبيق هذه القوانين. بهالطريقة ممكن نحسب التردد. In some ultrasonic transducer, one crystal is used as transmitter and as receiver, but it cannot transmit and receive at the same time. While in other transducer, one crystal is used transmitted and another crystal is used for receiver. بما معناته احنا في بعض الحالات نستخدم كريستال واحدة للإرسال والاستلام، ولكن حيكون اكو فارق بالزمن بين الإرسال والاستلام. ولكن إذا كان نريد بأن يكون الاستلام والإرسال بنفس الوقت نحتاج إلى استخدام نوعين من الكريستال. هاي ملاحظة حبيت أعطيكم إياها. Diagnostic sonography. Medical ultrasound is known diagnostic sonography or ultrasound sonography, which is a diagnostic imaging technique based on the application of ultrasound in human body imaging. It is used to to see some internal body structure, such as internal organs, muscles, joints, tendons, blood vessels, and to examine pregnant women. There are several advantages of using sonography on the other permanent methods of medical imaging, which are: one, it provides images in real time. Two, it does not use harmful ionizing radiation. Three, it is lower in the cost. Four, it is portable and it can be brought to the bedside. The basic idea of sonography is to send waves into the body, which are reflected at the interfaces between tissue, and the reflected waves are called cause. The return time of the waves indicates the depth of the reflecting surface. Typical sonographic instruments operate in frequency range between 1 to 20 megahertz. Also, frequencies of ultrasound between 50 to 100 megahertz are used experimentally in biomicroscopy technique in special regions such as interior chamber of eye. Variation of ultrasound images. The ultrasound images, which are also called sonogram, are created by three types. One, producing the ultrasound waves by the piezoelectric crystal transducer. The generated beam focused by phase array techniques to enable the ultrasound machine to change the direction and depth of focus. In the older technology transducer, the generated beam focused by lenses. An arc-shaped ultrasound wave produced from the face of the transducer. By this focusing on the wave travels at desired depth. The ultrasound beam is partially reflected whenever it incidents on a tissue layer of higher acoustic impedance than that of the tissue in which the beam is transmitted. These reflected beams return to the transducer in the same process it took to send the ultrasound beam. جميعا نعلم ان اي موجة راح تنتقل بين المادة او المواد راح تعاني مثل اي موجة ذكرناها من انعكاس وانكسار واختراق. كل هذه العوامل تعتمد على نوع المادة وبالتحديد الاكوستيك امبيدنس اللي هي مقاومة الصوت. فكل ما تكون مقاومة الصوت كبيرة مقارنة بالمادة اللي نريد ننقل الموجة إليه كل ما كان هناك انعكاس. هذا الانعكاس يأخذ نفس الوقت اللي أخذه في مرحلة الانتقال. لذلك نحتاج بشكل مهم جدا أن معرفة الأكوستيك امبيدنس اللي هو مقاومة الصوتية للمواد. 2. Receiving the echoes. When the return back ultrasound waves incident on the transducer the mechanical energy of ultrasound wave vibrate the transducer crystal and electrical pulses are produced. These pulses travel to the ultrasonic scanner. They are processed and transformed into a digital image. 3. The image display. The ultrasound image of an object in the body is displayed on the screen by pixel relative to the height and intensity of signals. This can be achieved by two things. First, the time it took the beam to be transmitted from the transducer and to be detected as echo waves by the transducer. And second, the strength of the echo waves. The formed image is displayed on the screen of the ultrasound scanner. Interaction of ultrasound beam with the tissues. When ultrasound beam is incident on the boundary between two media in the body, the beam will be attenuated. Attenuation is the reduction in the intensity of the beam by either the deflection or absorption of waves from the beam. The deflection of the wave occurs by reflection or refraction of the wave of the beam by homogeneous medium. When the medium is heterogeneous, the deflection is called scattering. مثل ما ذكرنا بأن عندما تسقط أي موجة فوق صوتية على حدود بين منطقتين في الجسم، هذه الموجة سوف تقل. اللي احنا نذكرها attenuation، بما معناه تقلل شدة الحزمة، فيحدث اما عن طريق انحراف او امتصاص الموجات من الحزمة. لما يكون الوسط متجانس سوف يحدث انحراف، اما عن طريق الانعكاس او الانكسار. في حالة إن كان الوسط غير متجانس فراح يحدث التشتت او الانتشار اللي احنا نسميه سكتر. There are three types of interaction of ultrasound beam with the tissue. 1. Reflection. The image of ultrasound is produced by the reflected proton of the beam. The transmitted ultrasound waves contribute nothing to image formation, but transmission must be strong enough to produce echoes at deeper levels. The percentage of reflected beam from the skin of the patient depends on three factors. First, acoustic impedance of the tissue. Second, the ultrasound diffraction job. And third, the angle of beam incidence. Acoustic impedance. When ultrasound waves pass from one tissue plane to the another, the amount of reflected beam is determined by the difference in the impedance of the two tissues. The reflection happens only when the impedance of the reflecting tissue is different from that of the transmit beam. The greater the difference between the acoustic impedance of two tissues, the greater the percentage of the reflected beam. The difference of acoustic impedance of most body tissues are small, except that of air and therefore air relativity very small and the bone relativity very large. An air soft tissue interface reflects more than 99% of the beam. This happens when the beam incident from transducer on the skin of the body. Therefore, lubricating specific gel is used to lubricate the skin of the patient to make coupling between the transducer surface and the skin to eliminate air and reduce reflected beam very much. Otherwise, a very small amount of the beam is around 1% is transmitted into the body, which cannot make any image for any part of the body. That's why we need to use gel to get the good image. Second, ultrasound gel. The use of ultrasound gel between the transducer and skin of the patient is an effective means to reduce the beam reflection and increase the beam transmission. The skin of the body normally reflects more than 99% of the beam when the beam incident from the transducer on the skin of the body. Therefore, a specific lubricating gel is used to lubricate the skin of the patient to make coupling between the transducer surface and the skin to eliminate the air reduce the reflected beam from the skin very much. The sonar lubricating gel has very specific characteristics. It should have acoustic impedance equal to the soft tissue. There should be no difference between the acoustic impedance of the gel and the skin. The use of ultrasound gel between the surface of the transducer and the skin of patient is an effective means to reduce the beam reflection, increase the beam transition, increase the echoes from the tissue back to the transducer and produce good image. Third, quarter wave matching. There is a big difference between the acoustic impedance of piezoelectric material and the human body in medical ultrasound transducer. The impedance are mismatch, which gives bad transmission of the beam to the tissue of the body. There it's vital to use matching material to couple this impedance. It is found that an acoustic matching material of thickness equal to the quarter of the wavelength of the sonic beam is vital to solve this problem. The acoustic impedance of the transducer and that of the soft tissue, which is very close to the relationship. The quarter wave matching material enhances the transmission of the ultrasound waves from the transducer to tissues of the body, and also it improves the transmission of ultrasound pulses returning from tissue back into the transducer. This matching material can be manufactured using a mixture of aluminum powder and epoxy resin. Angle of incidence of the beam. The angle of incidence between the ultrasound beam and the reflecting surface play a very important role in the amount of reflection. When the angle of incidence is large, the this beam is reflected in medical ultrasound transducer, at which ultrasound transmitted and received no reflection of ultrasound happen when the angle of incidence is greater than 3 degrees from the perpendicular. The best reflection occurs when the incidence angle is 20 degrees. There is no transmitted waves and there is totally internal reflection. Therefore, the expert of radiologist is very important in good image by sonography. The amount of reflected beam at perpendicular incidence of the beam on the surface is given by Z2 minus Z1 divided Z2 plus Z1 up to square multiply 100%, where R the percentage of beam reflected, Z acoustic impedance of medium 1, and Z2 the acoustic impedance of medium 2. The rest of the beam is transmitted in the medium, and the transmitted beam in the medium is given by T equal 4 Z1 multiply Z2 divided Z1 plus Z2 up to square multiply in 100%, where T the percentage of the beam transmitted, the sum of the reflected proton R and the transmitted proton T of the beam must be 100. Mean R plus T we should do equal 100%. Number 2, refraction. The bending of wave as they pass from one medium to another is called refraction. When ultrasound beam passes from one medium to another, its wavelength changes to accommodate a new velocity in the second medium, and its frequency remains constant. The transmitted photon of the ultrasound waves is refracted depending on the angle of incidence and the difference in acoustic impedance between the two media. When the beam strikes the second medium at an angle and some of the beam refracted, this will be result in the change in wavelength of the refracted waves, and this change in wavelength necessitates a change in direction of the waves. The angle of refraction governed by Snell's law, which is a formula used to describe the relation between the angle of incidence and refraction. Since the velocity of ultrasound wave is lower in the second medium, meaning the V1, the velocity 1 is bigger than the velocity 2. Therefore, the angle of refraction theta 2 is less than angle of incidence, meaning theta 1 is bigger than theta 2. For this slide, we explain the Snell law. When the wave beam transfer from media to another media, there the velocity is changed, and also the angle of incident is difference of refraction. In this slide to explain incidence angle here theta I, and refraction is theta R, and this is the theta transmission angle transmission, and we know the low impedance here and interface between two media. This is low impedance, and the up is low impedance and the down is high impedance. This is explain what they will happen in any wave beam. The Snell's law states that the ratio of the sense of the angle of incidence and refraction is equivalent to the ratio of phase velocities in the two media. Sine theta 1 divided sine theta 2 equal velocity 1 divided velocity 2. Because the frequency of ultrasound wave does not change in the two media, therefore the ratio of sense of the angle of incidence and refraction are equivalent to the ratio of the wavelength in the two media. Thus, Snell's law can be written as follows. Sine theta 1 divided sine theta 2 equal velocity 1 divided velocity 2 and equal wavelength 1 divided wavelength 2. 3. Absorption. Absorption of ultrasound beam is the removing of energy from the beam due to the force oppose the motion of the particle in the medium. This removed energy is converted to the heat. The absorption reverse conversion of ultrasonic energy to thermal energy. There are three factors determining the amount of absorption of ultrasound beam in the medium, which are the viscosity of conducting medium, relaxation time of molecules, and the frequency of ultrasound. For the viscosity of conducting medium, importance of viscosity is obvious in ultrasound beam absorption because ultrasound is being composed from vibrating particle. With increasing viscosity, the particle freedom decreases and the internal fraction increases. They will lead to absorption of energy from the beam by converting ultrasound energy to the heat, and the intensity of ultrasound beam decreases. اتضح هنا بأن الموجات فوق الصوتية هي عبارة عن جزيئات اهتزازية. فالزوجة عامل مهم في امتصاص هذه الموجات. عند زيادة الزوجة تقل حرية الجسيمات، يعني حركتها تكون قليلة، ويزداد بهالحالة الاحتكاك الداخلي بين هذه الجزيئات. هذا ما يسمح يعني موجات الفوق الصوتية بالمرور بحيث يتكون احتكاك داخلي، فحيكون هناك ضياع بهذه الموجات الفوق الصوتية. تتحول هذه الطاقة إلى حرارة نتيجة الاحتكاك الداخلي بين هذه الجزيئات، وبالمحصلة النهائية تقل شدة الموجات فوق الصوتية. بهذه الحالة حيكون هناك امتصاص لهذه الموجات الفوق الصوتية.
إلى هنا انتهي المحاضرة. نتمنى لكم موفقية ونجاح، وكل عام وأنتم بخير.